Mechanical engineering is a very broad major and one of the oldest engineering disciplines dating to the 18th century. It combines engineering physics and mathematics principles with material science to design, analyze, manufacture and maintain mechanical systems. Apart from mechanical engineering classes, as a mechanical engineer, you'll have to take a few electrical engineering classes to learn the basics of circuits as well as electronics, but not go as deep into that as electrical engineers might. You'll also be required to do a little bit of welding. This is where you learn that many different energy sources can be used for welding, including a gas flame, an electric arc, a laser, an electron beam, which I think is pretty cool, friction, as well as ultrasound. There's also a little bit of programming involved, where you learn MATLAB and C++, which is arguably the hardest programming language to learn. This is all to better understand the computer software, to translate everyday language, and develop algorithms for engineering problems. In the world of industrial fabrication, computers play vital roles in taking ideas from concepts to reality. Tools like CAD and CAM are used to design and analyze mechanical systems. What you may be wondering is, what's the difference between these two? CAD, also known as computer-aided drafting, is the process of using software and hardware to create, improve or otherwise tweak product plans, while CAM involves using computers to control the actual industrial process that results in the production of the prototype. Mechanical engineering can be broken up into different concentrations or subfields. These subfields include energy and power, HVAC, mechatronics, manufacturing and mechanics. However, in this video I'm gonna explain only these three. Let's first start with mechanics. Mechanics is the study of forces and their effect upon matter. Typically, engineering mechanics is used to analyze and predict the acceleration and deformation of objects under known forces and stresses. Mechanics can be divided into different subdisciplines: statics, physics of systems that are moving; dynamics, physics of systems that are moving; projectile motion, energy, momentum and more; fluid dynamics, properties and mechanics of fluids. There is a lot of calculus involved here. Examples of inventions in mechanics include a diesel engine, a cycloidal drive. This is basically a mechanism for reducing the speed of an input shaft by a certain ratio. Next we have HVAC, which stands for heat, ventilation and air conditioning. Sometimes the R for refrigeration is included. HVAC is based on the principles of thermodynamics, fluid dynamics and heat transfer. Its goal is to provide thermal comfort and acceptable indoor air quality. HVAC engineers play an important role in structures like apartment buildings, hotels, offices and homes. They find the most alternative method for heat distribution into different rooms of a particular building. You'll also learn more about things such as rooftop units, central heating units, air handling unit, which is used for heating, cooling, and filtering. There's also mechatronics. Mechatronics is the combination of mechanical engineering, electrical engineering, computer engineering, and controls. I must also explain that in some universities, mechatronics is its own major. It is very close to robotics. Some people say robotics is a subset of mechatronics. When you hear the word robotics, don't just envision a typical robot. It also involves advanced military drones with their own guidance system, automated medical equipment, as well as self-driving cars. One thing you may be wondering is, how much do mechanical engineers earn? According to the United States Department of Labor, the mean salary for mechanical engineers $89,800, with the top 10 earning close to $131,350. Don't forget to subscribe and click the notification bell so you'll be notified when I release a new video.